So del P may be written as del P over del xi plus del P over del yj plus del P over del zk. We know that this is the way to write gradient. Now if we have a body force in z direction, which is only weight, if we have only weight, what is the weight acting in z direction? That is minus, because it is acting in a negative z direction. So minus g delta m, so mass of the body multiplied by g, and this is a unit vector in k direction, is equal to del m may be written as volume. Volume is dx dy dz. So volume multiplied by weight density. Weight density is rho g. So rho g multiplied by weight volume is equal to weight acting in downward direction. So that's why we have a minus sign and we have a k here. So what is the net force acting on this fluid element, which I have just discussed, is equal to surface force plus body force is equal to minus del P plus rho g k multiplied by dx dy dz, and dx dy dz is nothing but volume of the chosen fluid element. Now if we have acceleration in x, y, z direction represented by ax, ay, az, then this net force acting on the fluid element is equal to del P over del xi, del P over del yj plus del P over del zk plus rho g k for per unit volume. For per unit volume is equal to mass multiplied by acceleration. So we are writing for per unit volume, so here we are writing mass per unit volume, so it will become density. So minus rho axi plus ayj plus azk. In this manner, if we write this vector form equation into 3 directional Cartesian coordinate system, then we will compare in x direction, y direction, z direction. Then this equation, vector equation, may be written del P over del x is equal to minus rho ax, del P over del y is equal to minus rho ay, and del P over del z is equal to minus rho g plus az. We compare del P over del x here. So del P over del x is equal to minus rho ax, del P over del y is equal to minus ay into rho, and del P over del z is equal to, since we have a del P over del z here and we have a k here also, rho g, and we have a az here. So that's why this equation will become del P over del z is equal to minus rho g plus az. So if we have a fluid element or we have a container filled with fluid subjected to acceleration in 3 Cartesian coordinates represented by ax, ay, az, then we have these pressure gradient in x, y, z. So del P over del x is equal to minus rho ax. So it means that pressure gradient exists in x direction, pressure gradient exists in y direction, and pressure gradient exists in z direction. Now if we have a fluid at rest, for fluid at rest, it means that ax, ay, az are 0. When we have ax, ay, az at 0, then these 3 equations in x, y, z direction may be written as del P over del x is equal to 0, del P over del y is equal to 0, and del P over del z is equal to minus rho g. Now these 3 equations we have already discussed for fluid at rest. These are the pressure variation equation. These represents that pressure does not vary in x direction, pressure does not vary in y direction. It means that in horizontal direction pressure does not vary, pressure varies only in z direction, and that is equal to del P over del z is equal to minus rho g, and minus rho g may be written as gamma. So minus gamma. Now if we have a fluid body, let us say we have a container here on the left hand side, we have this container which is filled with liquid, and this liquid container is falling freely. If it is falling freely, then what is the acceleration in z direction? Acceleration in z direction is equal to minus g. When you have a acceleration in z direction as minus g, what happens to our equations of pressure variation in this case? So we have del P over del x is not being considered here, because container is falling only in z direction. So, we do not have Ax, we do not have Ay. So, these two equation does not come into picture, or del P over del x is equal to 0, del P over del y is equal to 0. Only del P over del z is equal to minus rho g plus Az. If container is falling freely, or say let us assume that container is dropped from airplane and top layer is open, then Az is equal to minus g. When Az is equal to minus g, in this bracket g is cancelled and del P over del z is equal to 0. When del P over del z is equal to 0, what does it mean? That pressure does not vary in z direction. So, it means that if we look at this figure, pressure at this point is equal to P1, pressure at this point is equal to P2, and P2 is equal to P1 for freely falling container having liquid. It means that in case of freely falling container, this perpendicular column does not exert the pressure. So, it means that if container is open at the top, even if we make a hole at the bottom, when it is falling freely, this liquid will not come out of the container. This is the meaning of this statement, that del P over del z is equal to 0. It means that vertical column does not exert pressure in case of free falling container. Right. So, del P over del x, del P over del y, del P over del z is equal to 0, and P is equal to constant. Everywhere pressure is same in x direction, y direction, z direction.